Hello everyone, welcome to my chemistry channel BL the short and sweet in chemistry. Now I am going to explain the fundamental concept in organic chemistry which are very much helpful in class 11 and class 12 also. Now it is part 6 where electron displacement with reference to inductive effect I will explain. That means electronic displacement, electron moves from what position to what with reference to inductive effect. Then you will should know what is meant by inductive effect and what is electronic displacement. Now actually we know about the covalent bond in organic compound. Covalent bond is formed by sharing of electrons between two atoms. Two atoms may be same or different. If they are same, that is called homogeneous molecule. If they are different, that is called heterogeneous molecule. See, this is the homogeneous molecule and this is the heterogeneous molecule. Homogeneous molecule, the pair of electrons shared between two atoms. And that is in the middle, so it is homogeneous molecule. But here B is more electronegative than A. Heterogeneous molecule, let B is more electronegative than A. By chance also here A is more electronegative than B can be possible. But now I want to show B is more electronegative. Why? Because this pair of electrons which are sharing that moves towards B because B is more electronegative than A. Now if it is heterogeneous molecule, if B is more electronegative than A, the pair of sharing electron moves towards B, so electron displacement takes place. If suppose A is more electronegative than B, then what happened? The pair of electrons sharing that move towards A. And now due to different electronegativity, the question is what is meant by electronegativity? Electronegativity means it is only one tendency to attract electrons towards itself. If the electron attracted towards B, then electronegativity of B is more. Then what is electronegativity? Electronegativity is the tendency to attract electron towards itself. So here CX, see the carbon X is any electronegative more, that is maybe halogen let, and X is more electronegative than carbon, inductive effect arises. Inductive effect arises and electron moves towards X. And what is that mean? Inductive effect. This is a one type permanent effect. And what is that? Actually you can find others in case of presence of multiple bond. If there is a presence of multiple bond mean maybe double or triple bond. If double bond, that is alkene. If triple bond, that is alkyne. And here also electronic displacement takes place because you know pi bonds are very weak in compared to sigma bond. Similarly, resonance effect. What is meant by resonance effect? Resonance effect mean here delocalization of electron through resonance. Movement of electron one to other, and it is delocalization of electron through resonance. Hyperconjugation, there is no bond resonance. So out of four you will see first what is meant by inductive effect. Inductive effect, when you see, you start from the covalent bond, how the covalent bond is formed. Covalent bond, if there are two different atoms, then one should be lower, higher electronegative, other should be lower electronegative compared to other. That means if A and B are there, this is A and B, then what happens here? Either A is high electronegative than B or B is high electronegative than A. So now we will check here which one is high electronegative. Now the electron pair shifted to more electronegative. I told before also, when there is high electronegative atom is attached to carbon, automatically the electron pair moves towards the electronegative carbon, that is towards X. That means X is more electronegative than carbon. Suppose opposite case, when electron pair away from the X and towards C, that means X is less electronegative than carbon. Since carbon is more electronegative than X, that is why the direction of arrow changes and the shifting it changes. That means from halogen or from X towards C. Shifting of electron density, that is electron displaced. Either in case of X is more electronegative or in case of carbon is more electronegative, there is no problem. But movement takes place. Movement means towards highly electronegative. Now you can see B is more electronegative, I told. That is why the sharing of electron, pair of electron that towards B, because in B cannot receive 2 electron towards 100%, but it is partially towards B, because B is more electronegative. That is why it never forms any ionic bond, but it forms partially positive negative charge bond. That means it is not 100% that is separated by positive and negative charge, but they are separated by delta positive and delta negative. Delta positive means partially positive charge. Delta negative means partial negative charge. This is due to possible that when one is more electronegative than other. Let us see all 4 bonds are there in carbon. With one bond, here with one bond, this here halogen or X group is attached, which is more highly electronegative than this. Then here you can write 3 bonds as it is, but a pair of electron towards X, this pair of electron towards X. That means what happened here? This is towards X. Then here you can say this X achieve one partial negative charge, because why? Because X is highly electronegative than carbon, and carbon here acquires a delta positive. What is the difference with delta positive and single positive, or delta negative and single negative? When 100% the ions are separated by losing or gaining electron, if losing positive charge, if gaining negative charge, that is impossible in case of ionic compound. In ionic compound, there is totally transfer of electron, either losing or gaining 100%. And now here it is only delta. Delta means partially positive and negative charge. So how the electron moves? The electron moves, here see the electron moves towards X. Why? Because it is delta positive, here it acquires delta positive, and here it acquires delta negative. More electronegative atom occupies partial negative charge, and more electronegative atom less electronegative, that is partial positive charge. Let us see this one, where you can see C is delta positive and X is delta negative. Delta means, again listen, delta means partial. And suppose here, this first case, this is X is more electronegative, that is the arrow mark towards X. If C is more electronegative, the arrow mark towards C and having partial negative charge. Are you clear? If which one is more electronegative, the arrow mark towards it. In first case, you can see X is more electronegative than C. In second case, you can see the C is more electronegative than Y. That is why here C minus delta and plus delta charge is there. Here in this case C is more electronegative than X. In this case here the X is more electronegative than C. Electron displacement takes place towards the highly electronegative atom. And after that you can see if it is attracted towards highly electronegative atom, before that carbon which is present, that is called first carbon. Just like here, see, just like here in the last you can see this is the first carbon, this is called first carbon, and this is second carbon, third, fourth. That means the Cl is more highly electronegative than carbon. That is why here the displacement takes place. That is called first is induced by the help of this chlorine, which is highly electronegative, and the second carbon is induced by the third. Similarly, first carbon is induced the second, and second carbon induced the third carbon. One by one is induced by the other. That means C1 is induced by that is Cl minus negative charge, and here and the first carbon acquires a positive and second carbon induced by the first carbon, third carbon is induced by the second carbon. Like this here you can observe that is acquires one delta positive here, 2 positive, 3 positive, 4 positive. This inductive effect goes on decreasing. That means see here 1 plus sign, here plus plus plus, increasing plus, and that is 4 plus, decreasing with increase of displacement. When displacement increases, then charge is gradually charge is increases. That means inductive effect goes on decreasing and increasing on displacement. So here you can see that example CS3. Suppose you want to see one practical example. Let us ethyl chloride. Chlorine is a highly electronegative than first carbon. This first carbon, second carbon. The first carbon acquires a delta positive. Here acquires a delta positive. Here acquires a 2 delta positive because it is the second carbon 2 times. So what happened here? Here it is explained in this way. Cl3C2 hydrogen and Cl. Cl is polar. First you will see which is polar covalent bond, where there is highly electronegative atom is there to the and attached to the carbon. It is more electronegative atom. More electronegative. If more electronegative atom is present, then what happened? The electron move towards the more electronegative atom, and that is why gradually you can see it forms a polar covalent bond. It is polarized. Polarized means it is not ion compound or ionic compound, or can say electrostatic force the compound, but actually it is polar covalent. Why? Because the negative that is acquires a delta negative and the other one acquires a delta positive. So it is called polarized. Polarized means delta negative and delta positive charge existing. And carbon 1 gains partial positive charge. This is partial positive charge 1. And chlorine gains partial negative charge. Then after that what happened? Shifting of electron density is shown by an arrow mark. See here, chlorine is here. That meant the electron moves from this carbon 1. It is carbon 1, you know, this is carbon 1 and this is carbon 2. Carbon 1, the electron moves towards chlorine, delta negative charge, occupied delta negative charge, and here carbon 1, the electron moves towards delta positive charge. 1 delta positive charge, then carbon 2 acquires 2 delta positive charge. If carbon 3, 3 delta positive charge. That means here times the delta positive increases. And now carbon 1 having plus 2 partial positive charge, carbon 2 double plus 2, double delta plus. And we can say the polar covalent bond induces polarity. That you can see here the Cl3, CH2, Cl. Now Cl acquires a delta negative and this carbon that is 1 and this is 2 position. In 1 position that is delta plus and 2 position carbon that is double delta plus. Carbon 1 having delta plus, that is partial positive charge, and carbon 2 having 2 delta plus, partial positive charge. We can say that this Cl bond, this is the Cl bond, that means CCl bond. And what happened here? This induces the polarity to the adjacent carbon. If this is the number 1 and this is the electron moves towards chlorine, now this polarity induces the second carbon, that is 2, where delta 2 plus is used. That means first carbon 1 delta plus and second carbon 2 delta plus, where you can say the 1 is induced to 2 carbon. 1 carbon is induced the second carbon by the polar, that is called adjacent carbon. This type of displacement we can say is called inductive effect due to atom or group of atoms different electronegativity. If electronegativity different, then automatically one is it shows inductive effect, and this is induced by induces the other carbon atoms as they are far away from the CCl polar bond, and this is very important. It is also called permanent displacement. Now the substituents, that is what is mean by substituent? Substituent mean the carbon, any atom or group of atoms which will act as a substituent, and that is very effective towards the inductive effect. Then what are the type of substituents? Substituents may be either withdrawing electron or donating electron. When they are withdrawing electron from the particular atom, and that is called withdrawing effect, electron withdrawing nature, and that is minus I effect. And someone which is donating electron, that is called releasing capacity, that is called plus I effect. So one is negative minus I, electron withdrawing group, electron will withdraw from that atom, and one is electron will donate, that is called electron releasing, and that is called plus I effect. So one is called electron withdrawing effect, and other is called donating effect. So that is called minus I. What is minus I effect? The electron withdrawn from the substituent. And just like if chlorine is present, now if chlorine is present, then what happened? The electron is withdrawn from this side, that means from chlorine. And electron donating means the CH3 group is electron, that is alkyl group is present, which will donate electron. So it is related to hydrogen. How can you compare this one related to hydrogen? One is called minus I effect, other is called plus I effect. Electron withdrawing, that is called minus I effect. The atoms, what does it mean? That the atoms are group of atoms attached to the carbon if they are electron withdrawing nature. If they are withdrawing nature, that means electron can withdraw electron. That means here what happens? See here again, you see this one, the CCl bond, that the electron with the chlorine atom has the effect which will withdraw electron, that is called withdrawing minus I effect. And if it is donate electron, withdrawing nature, that means withdrawing electrons, that is high electron negativity. Decreasing order, that means now nitro group is more than SO3H, then CN, then COH, then fluorine, chlorine, bromine, iodine, OCH3, methoxy group, CCH5, phenyl group, and this is called that is withdrawing nature, minus I effect. Minus I effect means that is decreasing order. The maximum inductive effect where minus I, that is NO2. This one, this is the highest one, and which is the lowest one? This is the lowest one. So it can compare to hydrogen. It can be calculated with comparing with hydrogen. Similarly, electron donating plus I. Plus I mean the atom or group attached to carbon. Suppose attached to carbon, then they are electron releasing. Releasing towards what? That means here electron releasing group, they are called, example, alkyl group. If more alkyl group, more electron can be released, and that is called plus I effect. So here that means this is the how many methyl groups are here? 3 methyl groups. 1 methyl, 2 methyl, 3 methyl. Now here it is 2 methyl group and 2 methyl. It is 3 methyl and it is 2 methyl. It is 1 ethyl. Now 1 propyl. That means 3 carbon in a straight chain. It is 2 carbon in a straight chain. Ethyl group, methyl group, then hydrogen. That means they can release electron. That is why they are called plus I effect. The effect of inductive effect. That means what are the inductive effect that is having so many effect towards the compound. It brings changes in physical and chemical properties, but not important chemical, especially physical properties. What is the dipole moment, solubility, rate of reaction? That means it brings physical change. What are the physical change? That dipole moment, one is high, other one is less. Rate of reaction, solubility. Important in organic chemistry. Organic chemistry, how the alkyl halides are used alkyl halides are attached to a single chain or substituted chain, then what happens? Alkyl halide will release electron towards the carbon, and relative strength of acid and base also it is affected. Importance, that is strength of acid and base. Suppose withdrawing group is attached to carbon, then acidity increases. That means if withdrawing group is attached, it is stronger acid. If highly withdrawing group is attached, more effective, more withdrawing group nature, withdrawing effect, and that is called, it is a stronger acid, that is basic strength. Ammonia, we know it is a basic. If it is R primary mean R NH2, one hydrogen less. You know, in ammonia there is a presence of pair of electron, lone pair of electron. Primary amine also you can see, that is NH2. Here also attached a lone pair electron. If that is a presence of pair of electron on nitrogen, because it can release electron from the base of the nitrogen. If nitrogen can lose electron, not lose, if it is towards that releasing capacity is more, automatically on nitrogen, if a pair of electron is there, that is called Lewis base. Very important. What is Lewis base? If on the nitrogen, if a pair of electron is there and that can be released towards other, that is called Lewis base, RNS2, where N contains a pair of electron. Now you can see, if it is NS3, then it is also Lewis base, because the pair of electron on nitrogen can donate to other. Similarly, if alkyl group is attached to amine, that is NH2 group, here also same, that pair of electron on nitrogen, and ethyl side it can lose electron towards nitrogen. That means amine and methylamine, alkyl group is attached, so both are acting as base. They are called Lewis base. Alkyl groups are electron releasing group, increase the electron density on nitrogen. If it is on the nitrogen, if nitrogen present, then electron pair, that power, the density is more on nitrogen, so basicity increases. An alkyl group has plus I effect and order of plus I. Order of plus I effect mean, I told, if 3 methyl, that is more, 2 methyl, one state change just like propyl, then ethyl, then methyl, then hydride. Hydride negative charge. That means it can donate electron 1. After that it becomes to neutral hydrogen. So in acids also, you know, which are when there is minus I effect, then it is most good quality of acid, stronger acid. Now if you see fluorine, chlorine, bromine, iodine. Now fluorine is the highest electronegative. Fluorine, chlorine and bromine, if they are attached, then see how. Now here in acetic acid CH3COOH, here fluorine is attached. Now fluorine is withdrawing electron towards on. That means see the sign, from hydrogen, oxygen, carbon and CH2 group, the electron density moves towards fluorine. And here chlorine also same, but fluorine is highly electronegative than chlorine and bromine. That is why this is the order of the acid. Then fluorine when attached to acetic acid is more acidic than chlorine attached to acetic acid, then bromine attached to the acetic acid. This is the cause why fluoroacetic acid is more stronger than chloroacetic acid, that is stronger than bromoacetic acid, because fluorine has high electronegative than chlorine than bromine. I hope it is clear. What do you mean by acidity and basicity regarding to inductive effect, and what is inductive effect, how it is affect to the physical properties of organic compound, and how the basicity and acidity is affected by inductive effect. And so it is clear to you. Hope you will subscribe my channel BL Das, short and sweet in chemistry. Thanks again to all.